Let me start again. Hi, everyone. My name is Gonzalez, and I am the Maker Services Coordinator. I pretty much manage the Creat'R lab, which is the makerspace at UCR. And also in this workshop, hosting this workshop is Alvarez, who is the Innovative Media Librarian. And he'll be here to help out with, we'll both be pretty much teaching this workshop. He'll be helping out with any questions that you might have. So feel free to ask questions in the chat during workshop, and he'll try to get to you if I don't see it or if I don't get to you. But yeah, feel free to leave some questions in chat. So yeah, thanks again, or thanks for joining us for this Arduino workshop. So in this workshop, we're just going to learn how to use Arduino boards and how to make like simple circuits with it. We will be using Tinkercad to do that, which is a free simulation software for Arduino. And I guess we could go ahead and get started. So, okay, I guess before we go into Tinkercad, I'll just go over kind of like what an Arduino board is. So an Arduino is a microcontroller. And you can see the different components in here. So you have your digital pins right here, and then you have your analog pins right here. So the interesting thing about the Arduino is that because we have digital pins, we're able to control whether these pins, like we could turn off the pins on or off using code. So we could actually program, some things to control different components using code. And then down here, we have the analog pins. So these are, constantly running. We're not necessarily able to control these, but we have, like 3.3 volts, 5 volts, ground. We also have a voltage input, so we could actually power the board using this pin. Yeah, we'll kind of. You'll see this more once we get into Tinkercad, but just wanted to go over it just a little bit before we go in. So to use Tinkercad, you just go to tinkercad.com, and then let's see. Let me see if I can copy and paste this into the chat. All right, so once you go to tinkercad.com, you should see somewhere on the top right, you should see sign in, and you could actually just sign in using a Google account. So you could even use your UCR Rmail account to sign in into Tinkercad, so you don't have to actually like sign up. But I'll give you like a minute or two to do that if you want to follow along. And then once you do sign in, so Tinkercad actually has, a basic 3D modeling feature, but we'll be using circuits. So on the left-hand side, so once you log in, you should see something like this, right? And then on the left-hand side, you'll see circuits. So go ahead and click on circuits, and I'll let you. I'll give a minute for everyone to do that. All right, so once you sign in, you'll see on the left-hand side again, click on circuits, and then we're going to create a new circuit. So just click on create a new circuit. All right, so this is circuits. It's a cool free simulation where you make circuits, and you could actually use an Arduino board. So if you don't have an Arduino board on you, or maybe you never used an Arduino board before, you could use the simulation to test out your circuits and kind of learn how to use it before going in and actually creating circuits on the Arduino board. So what we're going to need is one Arduino Uno R3. So under basic components, if you just scroll down, you'll see it. It looks like this. So I'm just going to click, right, and then move my mouse over, and then I'll click again to drop it. If you scroll, you could use that. If you scroll, that'll zoom in and out. And then if you click on any of the empty space, if you click and drag, you could kind of move around the area and the components. So I'm going to move this right here. So after we put in our Arduino, we're going to put in a breadboard. So just do a small breadboard. I'll put it right here. And after that, we just need a resistor and an LED. So I'm going to add a resistor and add an LED. Okay, so I'm actually going to put the LED right here just so we could just go over basically what a circuit is for those of you. Okay, so the first thing we're going to do is, so here's our Arduino, right? And pretty much this is going to be powered. So I mean, the example here, it's getting powered through a USB cable. So you could connect an Arduino to a computer to power it. You could have a battery. There's like battery attachments that you could plug into here. You could even have power coming in through V in, which is voltage in, and the ground. But in this example, they're just they're showing that we're powering it through the USB cable. So anyway, so I mean, once given that our board is powered, now if we look down here again to this power section, we have 3.3 volts, 5 volts, and ground. So once it's powered, it'll always be giving, this pin will always give out 3.3 volts, this pin will always give out 5 volts, and then these will always be ground. So ground is pretty much 0 volts. So the first thing I want to do is I'm going to go from 3.3 volts. Let me see. So I'm going to go 3.3 volts. So what I could do is just click once, right? And then click again where it says anode. So it's like the bent part of the LED. And then I could change the color. So kind of like the general practice is that voltage or power or like, anything that gives electricity will be red. And then, let me see. And then, so once we connect, our voltage cable or voltage wire, I'm gonna go to ground, and then I'm gonna add it to the other end. So the other end's a straighter wire. Okay. Let me just move this. It's kind of hard to see. And then generally ground, you use black wires. So, I mean, it doesn't really matter the color of the wire, but this is kind of just the general, practice, just so you always know what's electricity and what's ground. Okay, so by us connecting it this way, so now we have a circuit. So first, what is a circuit? So here's a better example. So you could ignore the resistor right now, but so you could see that, well, this one's connected to 5 volts, right? But we have electricity, right? This is high voltage, right? So then what happens is, so a circuit is pretty much an enclosed loop in which electrons can, flow through. And when electrons are flowing, right, and we have current, that allows electrical components such as like an LED to have power. So it powers up these electrical components when we have the current of electrons, flowing through the circuit. So it starts from 5 volts. So it always goes from high voltage to low voltage. So we go 5 volts, right, down here, right? And then it would go through the resistor, and then through the LED, and then back into ground. So now we have a, unless the board isn't powered anymore, we have like a constant circuit of electrons flowing as we go from high voltage to low voltage, which is ground. So again, ground is 0 volts. So this is pretty much a basic circuit. Right? So I'm gonna go back here. So now actually what we could do is now on the top right, if we click on Start Simulation, you can see that, so now it kind of shows that it's plugged in, and you see that it's on. But we are seeing that, well, it's showing that the LED is actually burning out or exploding. So if we were to do this in real life, what would happen is the LED would it wouldn't really explode, but you'd probably hear like a little pop. And so pretty much what's happening is there's too much current, and it's like too much current going through. So there's too much like electricity going through the LED that it can't handle it. So that's where our resistor comes into play. So before we could do anything again, we have to click on Stop Simulation. All right, and then I'm going to, so you could delete wires by clicking on them and then just hitting backspace or delete. So now what I'm going to do is I'm going to add this resistor. So what resistors do is they slow down current, and by slowing down the current, it kind of it allows pretty much the LED to be able to light up without it burning out or like breaking. So now you'll see if I go from 3.3 volts, right, through the resistor, I'll change this to red. And then I'll go from the other end of the resistor to this this bent curved side of the LED. And then I click on red. Right, so now with our circuit, we added the resistor, right? So now if we kind of trace the flow of electricity, so it goes from 3.3 volts, so this is high voltage, right? So now we're going this way through the resistor. The resistor is slowing down the current, right? So now electricity is going through the LED and then back into ground, right, which is low voltage. So now we have this current. And now if we click on Start Simulation, you'll see that the LED is lighting up correctly, and it's not, exploding or burning out or anything like that. So so now we've just created a simple circuit. Are there any questions before we move on to the next part? So the next part, we're actually going to be going into code and learning how we could use the digital pins to actually control this LED and turn it on and off using code. But are there any questions before we move on? Okay. But if anything pops up, just feel free to leave a question in the chat, and either Alvaro or I will get to that question. Okay, so now we've created a circuit, right? Using pretty much like, this is pretty much analog, right? So this is, so again, we have constant 3.3 volts, right? And then we have ground. So for us to be able to control whether the LED is on or off, we probably have to physically or have a switch or something like that. Pretty much cut off the flow of electricity, right, to turn it off, and then have it connect again to turn it on. So instead of using a switch or taking this, removing the wire manually and then putting it back in, we could actually do that using these digital pins and by using some coding. So I'm going to, I could do this for you. So let's see. Oh, actually, yeah, let me go over the breadboard first before we get into coding. So, so this breadboard, so pretty much what this allows you to do is you could, you could build your circuits and test out your circuits without, I guess easily, so you don't have to like actually connect the wires, and twist them or solder them. It's a good temporary like circuit building tool. So the way that this works is if you hover over it, you can kind of see that there's green circles. Like, so if I hover over any of these, there's green circles horizontally. So what that means is that all of these pins are connected. So if I connect a wire to, let's say, this pin right here, everything that has a green circle around it, right, horizontally, as you can see, those are also connected to that pin. So for example, I'll go ahead and delete these wires right here. So for example, if I go from 3.3 volts, right, and I'm gonna put it on the plus, right? So the plus is voltage. And then I'll just change this to red. Okay, so okay, so as you can see, and I mean, it doesn't have to be the leftmost pin. I just decided to do that. But if I plug in, so now that I plugged in 3.3 volts, right, into this pin is now connected to all of these pins as well. So now all of these pins, if I put any wire here, it'll be connected to 3.3 volts. So it's as if I connected those two wires together. So now, if I choose like this pin, right, and I have this wire going out, now, oh, well, I have to connect it to something. So I guess I'll connect it here, right? So now what's happening is, I mean, if this were connected to ground, right? So now we have like a flow of electricity, we have current because we have high voltage and low voltage, right, in the circuit. So 3.3 volts will be going through this wire, right? And then what'll happen is because it's connected to the same row and all of these pins are connected, right? So now electricity is flowing here through now this wire, right? And then through the LED and then into ground. So now we have our circuit. So that's kind of just an example of how these work, right? So generally on a breadboard, you'll see that you have like a plus and minus. So this is for ground and voltage. So it'll be easy to kind of, so if I connect this to ground right here, and then what I could do now is I could, put my LED here, like kind of in the middle, right? And so now from here, right, I could, connect ground and voltage to any of my components in the breadboard, or like the middle part of the breadboard. So, so the middle part of the breadboard, right, the part that's not voltage or ground, or I guess specific for voltage or ground. And I mean, these pins work like normally it's just kind of labeled as voltage and ground. But inside, you'll see it's a little different. So these ones are connected horizontally, and then these ones are connected vertically, like with these 5 pins. So as you can see, as I hover to these different pins, now you'll see that these green dots or these green circles are all vertical. So it's like these 5, all of these 5 pins are connected to each other. So then if I hover over here, like all of these 5 pins are connected to each other. So it's a little different in that these ones are connected vertically. And then these ones are connected horizontally. But the nice thing about Tinkercad is it kind of shows you. So it's like a little guide to show you what, what other pins are connected to these pins. So for example, if I wanted to, well, I have my resistor first. Okay, so what I could do, one thing you'll notice too is that, so again, these 5 pins are connected, right? So what what that means is if I, connect, oops, so if I connect power to one of these pins, right? So now all 5 of these pins are connected to voltage, right? So I have electricity, like I have high voltage connected to these pins. These are not necessarily connected to these 5 pins, right? So if I hover over these 5 pins, you'll see that the green circles aren't highlighting over here, right? So these are this bottom half is completely separate from this top half right here, and the reason why is because use these for chips, and usually chips you kind of put in the middle, kind of like, I mean, we won't be using chips, but if you were to use chips, you'd have one end with the pins going into these pins, and then the other end going here, and that allows them to be separate. So yeah, but what I could do is you could actually, bridge these together by using a wire, or you could even use a component. So for this example, we'll be using the resistor as kind of that bridge between these 2 pins. So now if we trace it, I'm going to go with this red. So now if I go from 3.3 volts, right? So I'm going to trace it, follow this wire, right? Now it's connected to here, right? So now it's going through the resistor, right? And then now, after the electricity passes through the resistor, all of these pins are now connected. So now I could go from this pin to my LED, right? And then from here, the LED, I could go to ground. Oops, not that one. I could go to ground. All right, so, I mean, it's not really, I mean, you could organize it a lot better, but, so again, if we trace this, so we've got 3.3 volts, right? Well, I mean, we have ground and voltage, right? So high and low voltage. So now we have our circuit and we have our current flowing. So now we're going through this wire, right? Now through this wire right here, through the resistor, now through this wire, through the LED, to the other side of the LED, and then now this goes to ground, right? And then now we have an enclosed circuit, and if I actually run this, I'm gonna click on Start Simulation. You'll see that now the LEDs, the circuit is what's it called? The circuit is connected correctly, and my LED is turning on. Sorry. Okay, so now that we've gotten that working, let's see. So now we could get into some basic coding and learning how to use coding to control these digital pins over here. So what you could do now is if you click on code, right, on the top right, So Tinkercad has a few different options for you as far as how you want to be able to program the board and tell it what to do. So there's this block coding, which kind of simplifies it. But what we'll be using is text. So if you click on this drop down, go to text, and then just go to continue, and then you could let me see. You can leave that there. We'll go over that. So what this text is this is the code that we could upload onto our Arduino board, right? And what this will do is it pretty much tells it what to, what to do. And the way that Arduinos work is it's a loop. So when we tell it to do something, it'll do it continuously until it loses power. So just to go over basic coding, let's see. Okay, so I'll go ahead and show you here. So when coding for Arduino, so it uses what they call, so the language that's used is called Arduino C. So it's Arduino C, which is very similar to, it's pretty much like Arduino's like version of like C or like C++, which is a popular, so C, I'll just say I guess it's close to C++. So it's similar to this this programming language, which is a very very popular programming language. I think mainly it's used for creating programs for Windows computers, but yeah, so we'll be using this this language. So if you know C++, this will be very familiar to you. The only difference is that so in Arduino C, there's pretty much three. So you don't have to delete this. You can if you want. But what I'm going to do is I'm just going to delete everything that's in between these curly brackets, right? So open curly bracket and close curly bracket. So I'm going to delete this pin mode 13, and then we'll type this up again after. So Tinkercad kind of just provides that just as like a little like template or like sample code. So again, in between these curly brackets, I'm going to delete that. So now I'm only going to have where it says void setup, use open close parentheses, and then below that I have an open curly bracket and a closed curly bracket, and then again void loop parentheses, and then open and closed curly brackets. So with Arduino, the way that the coding is set up is that there's essentially 3 areas that you can insert your code, enter your code. So those 3 areas are, I'm gonna put space right here. So the first area is right here above void setup. So outside and above void setup. So this is where you're able to create your variables, call in new libraries, and pretty much it's primarily for those 2 things. So these are things that you want to be accessed in the rest of your code. So the first thing I'm going to do here is I'm going to say int, right? And then I'm going to type, actually, let me zoom in so it's a little easier to see. How do I do this? I guess I can't. Anyway, hopefully you could read that. Okay, so I'm going to type in int, and then I'm going to say LED pin, put a space, and then put equal, and then let's use 7. So, and then a semicolon. So this is how we set up a variable. right? And the way that variables work is I like to think of them almost like nicknames. So, for example, if I were to use this variable, so this is the variable name. So I named my variable LED pin. So if I were to use this anywhere else in the code, because I set it equal to 7, it's going to be as if the number 7 were present. So just to do like simple arithmetic, if I say 3 plus LED pin, right? So because I set the LED pin equal to 7, it's going to be as if it says 7 instead of LED pin, right? So now, right, 3 plus 7 equals 10. So the same case would be if I were to say LED pin, right? It'll equal 10, right? Because so what variables do is they hold pretty much a piece of data. In this case, we set our LED pin, right? So again, this is the name of our variable. This part before it, the int. So int is short for integer, right? So we pretty much set it to be an integer variable, so it'll hold pretty much whole numbers, right? So so I guess going from the beginning, right? So we said int, right? So we're setting up an integer variable, right? So because we want to use a whole number. And then this is the name of our variable, LED pin. So you can name this whatever you want, just as long as it's not a word that's already, or something that's already being used, or what they call reserved words, which are words that are already used in the software, or maybe you have it in a library. So for example, I can't name my variable int, or I can't name it void, or I can't name it things that are already used in the language. But for the most part, you most likely won't run into that issue. So like the best practice for naming variables is naming it something that's related to what the data it'll be holding. So for example, I named it LED pin because this is the number. So the number that this is holding will be the number of the digital pin that we'll be using. So so you pretty much want to name it so that when you're going over your code, you kind of know what that variable is used for, right? So so this tells it what type it is. So we're just going to be using integer. So int LED pin, that's the name of my variable. And then now I'm setting it equal to 7. So now my LED pin variable is holding the number 7. So every time I use it elsewhere in the code, it's as if the number 7 is. So if I were to change this, let's say to 5, right? So now if, and you could actually run arithmetic in C++, in Arduino C. So what'll happen is, so now it's saying 3 plus LED pin. So LED pin is holding the number 5. So it'll be as if the number 5 were here, right? So now I know that's 8. So this is also true. So LED pin. Oops. Okay. So again, so 3 plus LED pin. So LED pin is holding number 5, right? So it's as if the number 5 were here instead of LED pin. So now it's 3 plus 5 equals, and we have 8, right? So that's kind of like basically of like how a variable works. In here, we'll only be using an integer variable, but there's different types, such as character, string. So so for a character variable, I'll say like letter equals, let's say V. It uses like single quotation, right? And then so a character holds like one, like it only holds an individual character. So this could be a letter, a number, a symbol, but it's only one, like a single character, right? And string is it's like a succession of characters. So I could say string, I don't know, I'll just say name, and then equals, let's say 5, right? So a string could have a combination of different characters, and this could be like spaces and numbers and different symbols, but anything that's within the quotations, it'll hold. So yeah, so this could hold like words and like, yeah, again, a combination of characters. But we won't be using that today. That's just kind of to show you, the different types of variables that could be used. But we'll just be using integer variables. Okay, so I'm just going to change this to 7. Okay, so again, so above void setup, right? This is where we create our variables or call libraries. You don't have to worry about libraries, but pretty much libraries are like sets of code that are already created, and then you could use that. So it's you could use it to kind of take parts from existing code, which is what the library is holding. So the library holds like existing code that you could reference and use instead of you having to type out all the code by yourself again. And but yeah, anyways, so but we won't be getting into that today. So we'll just be using variables. So again, variables go above void setup, right? So the next part is void setup. So just kind of like as it's named, this is where you set up your different components and set up other things in your code that you need to set up before it runs void loop. So void loop is your main code. So the difference is void setup runs first, but it only runs once. Whereas void loop runs after void setup, but it runs continuously. So this is good for things like, so what was here earlier was in the code, they were setting up our pins that we're going to be using, our digital pins. So we could actually do that. So this actually uses what's called the function. So a function is just kind of, so if I say pin mode, right, capital M, and then open parentheses, and I'll say LED pin, comma, and then I'll say output, close parentheses, and then semicolon. So in Arduino C and C++, you have to end every statement pretty much with a semicolon. So that's how the language knows that that's the end of that statement. So so you can see here int LED equals 7, I have a semicolon, and you don't have to worry about void setup because you need it to be open. So this is the curly brackets are pretty much what closes it. But so don't worry about void setup, but anything inside void setup and anything inside void loop, each statement needs to be ended with a semicolon. So so just to go over this, so pin mode is like a function. So it's an Arduino function. So what it's doing is in the Arduino library that's already built in, the code for this that allows us to set up our pins is already written out. So we don't have to actually like write it out ourselves. So it kind of makes it easier. So this pretty much tells this function, we use it to say which pin that we want to turn on, or not necessarily turn on, but we're telling the Arduino what pin we want to use. So in this case, I have LED pin, right? But remember, we set LED pin equal to 7, so it's as if we have the number 7 here, right? So we're telling it, the Arduino, through this line, pretty much that we want to use pin 7, and we want to make it an output, right? So again, pin mode, right? Then LED pin, so that's, so this is LED pin is equal to 7, so this first part, again, is telling the Arduino what pin we want to use. In this case, oops, that's pin 7, right? And then the comma, and then we have output. So this could be output or input. So the difference is output. This will set up the digital pin to send out voltage or power, right? Where input, it will be receiving it. So if we were to use input, we could turn a digital pin into an input pin. Oops, let me take that. Oh, let's see if there. Okay, so if we say input, right? So pretty much by putting this, it's saying that we want pin 7 to be an input pin, which means it'll receive voltage. So generally people use this for kind of analyzing and detecting like how much voltage is going in. But we won't be doing that today, so we just want to use output. Okay, so now we set up our LED pin, so pin mode, right? We're using the Arduino function pin mode, and then in open parentheses, and then we have LED pin, which is LED pin that is our variable, which is holding the number 7. So we're saying that we want the Arduino to know that we are using pin 7, and we are making pin 7 an output pin, right? So we're going to use this to send out voltage. All right, so this code is only going to run once because it is in void setup, right? So code it runs from top to bottom. So if we go to the top, so this is creating our LED pin variable, and we're setting it. It's an integer variable, and we're setting it equal to 7. So now every time we reference LED pin, it'll be as if we're using the number 7. Then we go to void setup, and then we just have this one line which says pin mode, which is our Arduino function that allows us to set up a pin. And in the parentheses, we have our pin number, which is 7. So we're telling it to you that we want to use pin 7, our digital pin 7, and we want to make it an output so that we could send out voltage. So, and when we send out, when we turn any of these pins into an output pin and it's sending out voltage, it sends out 5 volts. But it will be fine because we have our resistor that allow us to use our LED. All right, so after we use void setup, we could go into void loop. Again, this is where our main code runs. So after it runs these lines, it's going to run whatever's inside these curly brackets and continuously run those until the Arduino is turned off, essentially. So, okay, so the first thing we want to do is we want to turn on pin 7 and give it 5 volts. So to do that, I use the Arduino function digital write. So you'll notice that the second word is capitalized. So then, and note that so when you set up your variables, note that it's case sensitive. So it has to be every time you use this to reference it, it has to be exactly typed exactly the same, even like obviously like spelled the same, but also like capitalization as well. And the same goes for when using functions. You have to make sure that it's correctly. I mean, I know we don't really see how these are spelled, but these are the correct spellings for it, and you just have to make sure that you follow it. So, so it's going to be digital, right, lowercase, and then write is going to be what's it called? The W is going to be capitalized. Right. So once you put digital write, we're going to do open parentheses, and then we're going to say LED pin, right? So we're saying like, oh, okay, we want to use our, we want to use pin 7, right? And then we're going to say hi. So the way that this digital write function works is that the first part in the parentheses, it's the same where this is where we say like what pin we want to use. So again, so we're saying we want to, we want to control or use pin 7, right? LED pin, because our LED pin variable is holding the number 7. And then the second part is, so it could either be high or low. So, so if we say high, then it's going to give the pin 5 volts. And then if it's low, then it's going to give the pin 0 volts. So, 0 volts. So pretty much when it's high, it's going to pretty much turn on the pin and give it electricity. And then if it's low, which is low voltage, it will set the voltage to 0. And because we don't have, we're not going to have a I guess, flowing electricity from high voltage to low voltage, it's essentially going to turn off that pin, and then that will also turn off that circuit as well. So let me go ahead and delete this. Okay, so in void loop, right? So again, this repeats, right? So this is our main code. So actually, we could try running the code right now. So I'll go ahead and I'll put this in the chat just for your reference. Oops, let me try this again. All right, so again, going from the top, we're creating our integer variable and we're setting it equal to 7. So now every time we reference LED pin, the LED pin variable that we created, it's as if the number 7 is there. Then we go to void setup, right? And this only runs once. So then this just sets up the pin. So we're setting up pin 7, telling the Arduino, hey, we want to use pin 7 and we want to make it an output. So we want to be able to send out voltage, high voltage through pin 7. Then after void setup, we're going to get into void loop, which is our main code. And then right now, all we have is our digital write function, which allows us to control the pin that we put in here. So in this case, we're using our pin 7, and we're saying we want it to be high voltage, right? So that pretty much turns on the pin because it's giving it 5 volts, right? So now if I do start simulation, right, you'll see that, oh, oops, sorry, I forgot to connect this correctly. So I'm going to delete this wire. Instead of going from 3.3 volts, I'm going to have this wire go to our digital pin 7. So again, I'll start from pin 7. So I'll go from digital pin 7, and then I'll connect it to the voltage row on our breadboard, right? So now if we trace this, our circuit, it's kind of hard to see. Okay, so now if we trace the circuit, there you go. Okay, so we're going from pin 7, right? Given that there's high voltage, now we have our circuit and we have electricity running or flowing. So if this pin is on, which we set it to be on, then we have 5 volts going out through here, right? Then now through this wire, right? Now through the resistor, right? Which again, the resistor slows down the flow of electricity. It slows down the current so that we could use it for the this LED, which can't handle too much current. So now it goes through the resistor, right? And then through this wire, through the LED, then through this wire right here, which is connected to this row, our ground row, and then that's connected to ground, right? So now we have our closed circuit from high voltage to low voltage. And then, so now once we press start simulation, you'll see that the LED is turning on, right? Because we pretty much told the Arduino to turn on and give 5 volts to pin 7. So now we have our circuit. So let's say we want to turn it off, right? So I'm going to click on stop simulation, right? And I'm going to change high to low, right? And then once I hit start simulation, you'll see that the LED is off, right? And that's because we don't have electricity flowing, because we have 0 volts here and we have 0 volts here, right? So then there's no flow of electricity from high voltage to low voltage. It's just they're just both 0 volts. So so I'm gonna go stop simulation. So now what we can do is using the code, we could actually have the Arduino board. We could program it to turn on the LED for 1 second, and then turn it off for 1 second, and then turn it on for 1 second, and have it, again, our main code, it loops. So once we write it out, it'll do it continuously. So we could actually program the light. So what we could do is, I'm just going to change this to high. We just want to start it on with digital pin 7 on and giving out 5 volts. And so now if I add a new line and I say delay 1000 and then semicolon. So this delay function, what this does is it waits this amount of time in milliseconds before it runs the next line, right? So if we kind of like, trace our code, right? So once it runs this line, it'll say, hey, I want to use pin 7 and I want to turn on pin 7. So I want to give high voltage to pin 7, right? So that's turning on the pin. Then when it reaches this line, we're saying like, okay, wait 1000 milliseconds, which is 1 second. So wait 1 second before you run the next line, right? So in the next line, what we could do is, we say digital write LED pin, right? Because we want to use pin 7, and then we'll say low, right? So now if we trace our code, what'll happen is when it runs this line, it'll say, hey, turn on pin 7 and give it 5 volts, right? Then we're going to wait 1 second, right? 1000 milliseconds before it runs the next line. And then after 1 second passes, we're going to turn it off. So we're giving pin 7 low voltage, right? Or no voltage. So that pretty much turns off the pin. And then the last thing we want to do is we want to say add another delay, right? Before it turns on the pin again, semicolon. And then so now once it runs this line, it's going to wait 1 second, right? And once it reaches the end of void loop, it's going to go back to the top. So if we trace our code, so we're turning on, giving 5 volts, high voltage to pin 7. We're waiting 1 second. Then we're going to turn off pin 7 by giving it low voltage. Then we're going to wait 1 second, and then it's going to go back. It's going to go back to the top to this line, right? To the top of void loop. So now it's going to do the same thing. Turn on, wait 1 second, turn off, wait 1 second, then goes back to the top, turn on, wait 1 second, turn off, wait 1 second. It's going to continuously do this. It's an endless loop until we remove power from the Arduino. So, so now what I'll do, I'll go ahead and insert this in the chat as well. Let me make sure it works first. So once I hit start simulation. Let's look at our LED. So it turns on for 1 second and then it turns off for 1 second, and then you can see that it's blinking, right? So it's turning on for 1 second and turning off for 1 second. So we're able to program that now into we could using our code, we're able to program that using the Arduino, so and coding. So I'm going to go ahead and insert this in the chat. So you have that for reference. Are there any questions? We're pretty close to the end of the workshop. If we end early, we'll be here until 3:30, I believe. Yeah, 3:30 to answer any questions. Okay, so we have a question. So if we could use, correct me if I'm wrong, but if we could use any of these pins, or if it has to be pin 7. So if I got that correct, so actually we could use any of these pins over here. So, and that's a good question. So if I delete this wire, right? And then actually, if I connect it to any of these pins, so I'm just going to do pin 12, right? I'll just change it to red. And again, the color of the wire doesn't matter. It's just kind of like, it lets us know what has, power or voltage, and then what's ground. And the reason why that's important, I should have explained this earlier, but the reason why we don't want to mix ground and voltage is if ground and voltage like touch directly, that could short the board. So you could damage the board or the components that are connected. So you want to make sure that, voltage is connected to voltage, and then, on the correct end of the components, so that, so for example, like the LED is specifically has like a voltage side and a ground side, right? So because we're connecting the voltage to this side of the LED, right? And then ground is connected to this side. They're not necessarily touching directly. But yeah, so that's just kind of, you want to make sure that that ground and voltage aren't touching. And you could kind of tell if the board is shorting, where, if you had a real, if you had actually had like a real Arduino in front of you, and you connected, and you created a circuit and you didn't see that voltage and ground are connected, or voltage and ground are like, so voltage and ground are like touching directly somewhere, then the board will short, and it'll probably get hot if you have it, and could potentially break if you have it on while it's shorting out for an extended period of time. But you'll notice if you plug in and give it power, right? So if I plug in the USB cable and none of these lights turn on, that there's that's kind of like a sign that it's shorting, or if you smell like something's burning. Well, it wouldn't necessarily burn, but you'll kind of like smell it a little bit, that it smells like something's burning. But anyway, so to get back to the question, so again, if I connect, pin 12 here, right? And then, so this will work too, but the only thing is we just need to change our code. One of the advantages also of using variables in code is it's easy for us, if the variable is used, throughout our code in multiple places, for us to change like this number, so we just want to change it to 12, we just have to do it once, and that's here, right? So for example, if I put this in manually, right, pin 7, pin 7, pin 7, and for me to change the pin number to 12, right, I'd have to do this all manually, right? So, but because we're using a variable, we could actually change, like we could control like all of these, right? and change all of them just by changing what the variable is equal to. And I don't think I went over this, but you could also, after you create the variable, you could actually change the number within the code itself, right? So like, let's say we had pin 7 here, right? But we actually wanted pin 12 to be used. I could actually go in void setup or void loop, but I'll just do it in void setup. And I could say LED pin equals 12. So now what's going to happen is 12 is going to replace whatever number was in the variable originally, right? So now if I click start simulation, you'll see that now it's working, right? So if I trace the code, I created a variable LED pin, right? And then I set it equal to 7. So now this is holding the number 7. But the moment that I reach this line, the number 12 is now what LED pin is holding. So it pretty much tosses whatever data is in that's in that variable, and then it replaces it with whatever we set it equal to. So from this point on, from this line on, LED pin will be equal to 12. So you could even use variables to your advantage throughout your code if you need, let's say, the pins to change, which I mean, there could be use cases for that, or if you need, like, if you're doing arithmetic, I could even say like this plus 1. I could say like 11 plus 1 or something. So what'll happen is now it'll actually like run this calculation, and then it'll say now LED pin will equal 12 because we said LED pin equals 11 plus 1, which is 12. So now it's going to be holding whatever, the answer, or not answer, but whatever this sums up to. Or so now if I click start simulation, you'll notice that the LED pin is still working, right? Because it's using LED pin 12. So, but that's just kind of like another example of how variables can be used in code. But yeah, so I'm going to take all of this out, and I'll just say this equals 12. Start simulation. So you can see that even though we changed the pin, so all of these work the same. The only ones, let me correct myself. So you could use pins 2 through 13, pin 1 and 0. These are used for serial communication. So that's communicating with other Arduinos or other devices, such as like a Bluetooth module, other, maybe like a computer or something like that, that's using like, that you need to communicate with. So these two pins, digital pin 0 and digital pin 1, are actually reserved for that. But you could use pins 2 through 13. You'll notice that there's like a tilde in front of like certain numbers, certain pins. So that just means that those are PWM pins, and you don't have to worry about that, but that just means you have extra control for certain components that support PWM. But for something basic like this, you could use any of these pins, even the PWM pins. So yeah, I guess to answer that question, so you can use any of these digital pins for what, for this, and you can control them. But again, it's only from pins 2 through 13. So those are the digital pins that you could control. Again, 0 and 1 are kind of reserved for communicating with other devices and components and modules. But you could control, what we're doing right here, you could use pins 2 through 13. Are there any other questions? Let's see. What we'll also do is we'll go over, I guess, like one more. We're going to take this a little, like one step further, and we'll actually program, 2 separate lights, and we'll show you how to do that. And actually that question about if we could use digital pins kind of like ties in nicely into that example. I don't see any questions. So again, if any questions pop up, feel free to enter them in the chat and we'll get to them. But I'll go ahead and go over like the last part of this. Okay, so let's say, so we got one LED, right, turning off and on. Let's say we want another LED to turn off and on. So let me actually get another LED, right? I'll change this to green. So you can actually program some very basic Christmas lights. Okay, so I'm going to put this here, right? Okay, so now what we'll do is we'll kind of do the we'll set up the circuit first, and then we'll get into the code. Oops. Let me zoom in there. Okay, so let me take that. Okay, so so we can kind of see here, right? So we have so we'll actually delete. We're going to delete this just because. So the voltage wire, or the wire that's connected to pin 12, we'll actually delete that because we want the pins going directly into, you know, its respective LED. So I'm actually going to delete this too, and then. So what I'll do is I'm going to add the resistor here, right? And then I'm actually going to minimize that. I'm going to get another resistor. I'm going to put here. And then remember that, so when you're looking at the LED in Tinkercad, the one that's kind of bent, that's where your voltage is going. So in a real LED, to tell the difference, this will be the longer end. So the longer end will be where you're connecting your voltage to, and then the shorter end will be going to ground. So I'm going to place that right here. Okay, so so ground. So we could actually use the same. We could use ground for both. Not necessarily the case for voltage. So I'm going to connect that to ground. Right. Okay, so let's say I guess we could use the same number. So we'll use pin 12 for the red and then pin 7 for the green. So we want to go from pin 12, right, to pretty much connect it to the resistor, right? So I'm going to change this to red. Okay, so again, so pin 12, given that it's on, right, it's going to be sending out 5 volts. So now it's going to go through this wire right here, through the resistor, into the red LED, and then out into ground, right? So now we have our circuit for the red LED, and then to create our circuit for the green LED, now we have to connect our other pin, which we'll be using pin 7 in this case. And we could actually leave it green so we know what wire is connected to what. So I'm gonna move this over just so it doesn't intersect with the red. So this black, and then we'll delete this wire, and then move over our resistor. Okay, so again, pin 7. Again, given that it is on, and we tell it, you tell Arduino to give it high voltage, this will. So we have high voltage going from here, right, from pin 7. Oops, place that. So again, we want that below here, right? So, oops. Okay, so from pin 7, right? If it's on, we have high voltage, right? Going from high voltage to low voltage. So electricity is going through this wire over here, through the resistor, which slows down the current. Sorry, I've been accidentally scrolling. Okay, so through the resistor, through the LED, and then through this wire, and then now this is connected to ground, right? So now we have our circuit here as well. Right, so we created our circuit for the red LED, and we created our circuit for the green LED. So now what we need to do is change our code. So the first thing we need to do is set up our variables. So again, I'm going to say int LED pin equals 7. Oh, sorry. Actually, let me change the name of these. I'm going to change this to red. I'll just say red pin and then green. Oh, I mixed them up. This will be red and this will be green. Okay, so and then we'll have to change these as well. But okay, so so we're going to look at our variables. So we created an integer variable called green pin, and that's we're going to have that hold the number 7. We also created a variable called red pin, an integer variable, and that will be holding the number 12, right? So now if we go to void setup, right? So now we have to set up both of these pins. So I'm going to say green pin output. So I'm telling the Arduino that we want to use pin 7, and then we want to make it an output pin. And then I'm going to do the same here. So pin mode red pin, and then output. Oops, output. So again, we're telling the Arduino we want to use pin 12, right? Because red pin is holding number 12, and we want to make that an output. Okay, so again, void setup, it only runs once. So now that we've set up our 2 digital pins that we're using, and we told Arduino what pins we want to use, and they're telling it that we want both of them to be output pins. Now we'll get into void loop, right? So I'm gonna separate these so it's easier to see. So digital write. Actually, let me do it from scratch. So digital write, right? So we want to be able to control the pin that we tell the Arduino to control. So the first pin we'll say is, we'll say, I guess since the red pin's on the left, we'll do the red pin first. So we'll say red pin, right? High, right? Because we want to give it high voltage. So this line again is giving the red pin, which is pin 12, high voltage, and it's pretty much turning on that pin, right? So then now we're going to say delay 1000 because we want to wait a second. I'm going to say digital write. I guess let me see. Let me simplify this first. So I'm going to say digital write red pin high, and then I'll say digital write green pin high. Right. So we'll see that both of our circuits are actually working. So I'm going to click on Start Simulation. Okay, cool. So now you can see that both our red LED and green LED are turned on, right? Because we're giving both pins. So the pin 12 and pin 7, we're giving them 5 volts because we said we're giving it high voltage, right? So so our circuits are running correctly. So now what we could do is we could actually We could make them blink. I guess we could have them alternate. So we'll do the red pin first. So I'm going to say red pin, digital red pin high, right, to give it 5 volts and to turn on the pin. Then I'm going to wait 1 second, and that's just delay 1000 milliseconds. Then I'm going to say digital right red pin low. So that's giving that, now it's giving the red pin 0 volts and essentially turning off the LED. And I'll say delay 1000, right? So turn on the red LED, wait 1 second, turn it off, wait 1 second, and then, so you could actually have like, I know we haven't really, or I haven't really been putting any like, I guess space between lines of code, but those don't, it doesn't really do anything if you have like space in between. It actually makes it easier to kind of organize your code, so you can kind of visually see like, okay, like at least I know this part is specifically for the red pin, and then this part will be for the green pin or the green LED. So I'll do the same thing here. I'll say digital right, green pin high, delay 1000, digital right, green pin low, delay 1000. Okay, so now, let me just clean this up. Okay, so now if we trace our code, right, in in void loop, right? So this is our main code. So we're turning on the red LED, waiting 1 second, turning off the red LED, wait 1 second, turning on the green LED, waiting 1 second, and then turning off the green LED, waiting 1 second, and then because it's in void loop, it's going to go back to the top, right? And then it's going to run each line and do it over and over until we turn off the Arduino. So now if I hit start simulation, you'll see that the red LED turns on for 1 second, then the green LED turns on for 1 second. So now we have kind of this pattern that we programmed with the code. And I'll go ahead and copy and paste this again into the chat for the reference. Let's see. Oh, there's a question. Okay. So I guess the question is, I guess what organization we're part of, and tips on materials to learn about Arduino, and some projects, and future workshops. So, so Alvaro and I are from UCR, which is a University of California, Riverside, and we're both part of the UCR library, and our so I guess this workshop is so we're under the research services department, and the Creat'R Lab makerspace. So the Creat'R Lab is our makerspace on the UCR campus, and so yeah, so we're from UCR, and let's see, tips and so for learning more stuff about Arduino, you can find it all over on YouTube. There's a good website called Instructables that you can find like cool projects. Instructables.com. Instructables. I think I got that right. Yeah. So Instructables.com. And then I could I'll put this in the chat. Actually, let me just copy and paste it just so I don't make a typo. Oops, this thing's in the way. Okay. Okay, so there's Instructables.com. So it's like a nice community for that people kind of share their projects. Usually they give like the code or the files or like instructions how to make different things. So like I guess here's a good example. It's like how to use an Arduino to make an obstacle avoiding Lego robot. So, I mean, this is, so it's using the an Arduino board and using like an ultrasonic sensor. It's like a distance sensor and then uses motors. So it tells you, they usually tell you what parts they use, and most people also provide videos and like pictures and stuff, which are very helpful. But you can find a lot of cool projects on there. There's also a company called Adafruit, so ADAFRUT. So they sell components and stuff like that, and like, they sell different like packs of like for projects, like they sell like project packs, so it has all the stuff that you need. They sell their own like Arduino boards, like smaller Arduino boards that could also be like, they have Arduino boards that are used for like making like smart like clothing, or like I forgot the term for it, but pretty much it's like you could make let's say like a Halloween costume and then have like LEDs or like sensors and stuff. Like you could use Arduino to control that. I'll add that here. There's adafruit.com. Oh, okay. Alvaro added it. Oh, oops. I think that was a private message. And then, but yeah, you can find projects all over. I don't know if you have any other websites, Alvaro, that.
I can't think of any right now. Yeah, like for me, I usually use Instructables. There's like a few more. There's some from like the Raspberry Pi organization too. Like it's similar to the Arduino, but it's more of a microcomputer, and it also has like the pins like the Arduino boards. It's like a combination of both. But there's also, like Ray said, a lot of YouTube videos out there. If you a lot of like people that have channels, they'll like post every week like projects. Like I know I found like stuff for like I was trying to make a BB-8, so I was like following different people that have like worked on that project, and then they share their process and like the code, what they use, links to buy like the stuff you need. So yeah, there's a lot of stuff. And I was gonna mention too, we if you want to keep an eye out for it, we're gonna start having like weekly meetups where you'll have a chance to come in and talk with us, show us your project, ask us questions if we could help you. So it'll be a collaboration thing between everyone. We'll have guest speakers too, like people that are working on specific projects, maybe once a month, like faculty that works on robotics, for example. They'll come in, talk about what they're working on, and if that's an interest to you, you can join and pick their brain and like just like for an hour or so, just talk. So keep an eye out for that, and I think that'll be like a really cool meetup. So.
Yeah. So for that, and like, so for any future events and workshops that we'll be having, you could find it at ucrlibrary.eventbrite.com, and I'll, oops, yeah. It's not linking out. Hold on, let me see if I could. Okay, so I mean, you could use this link as well, but it's pretty much just ucrlibrary.eventbrite.com, or you could use this link too. So any future UCR library events, or any of like our like Creat'R Lab or research services events, you'll find that on that Eventbrite. So yeah, let me see. So we have like a couple minutes. Does anybody have any questions before we go? But yeah, thank you everybody for for attending our workshop. Hopefully you learned something today. And yeah, if you have any questions, feel free to, you could contact us. So I'm just going to leave our Creator Lab email here. So it's Creat'R Lab. Oops. So this is kind of the email address for the Creator Lab, which is our makerspace. If you have any questions, like feel free to reach out. And yeah, thank you again for attending our workshop, and hopefully we'll see you in a future workshop. I mean, we'll be here for like another, what, 2 minutes, if you still have any questions, but if you don't, again, yeah, thanks for joining us.